Hello all and welcome to the YouTube channel Talk GCSEs, where I will be talking today about momentum. Now I'm going to explain momentum. It's a big idea for physics, foundation students and especially higher students. Now momentum is a measure of how hard it is to stop a moving object. It depends on two things: how much mass has something has, and how fast that something is moving. A heavy object moving fast has a lot of momentum, and a light object moving slow has less momentum. Now, I do want to say to you guys, if you do like my videos and you want me to create more and more videos, it will really be helpful if you guys can subscribe on the YouTube channel, and it will make it much more easier and gives me a little push to create more and more videos. Now, for your GCSEs, we need to understand this formula. The formula is P equals mv. So momentum is equal to mass times velocity. P is the momentum, which is in kilograms meters per second, and then mass is in kgs, and then velocity would be in meters per second. Now momentum is vector, which means it has a direction as well as a size, so velocity direction matters. If the direction changes, the momentum changes, even if the speed stays the same. Now, conservation of mass, we understand these units. I've just shown them to you again. Going on to a thing called conservation of mass, momentum, that is the core principle here. One of the most important rules is that momentum is conserved in a closed system. That means the total momentum before an event is equal to the total momentum after. Now, as long as no external force acts on the system. So for AQA specific students in a closed system, the total momentum before and after an event is the same. So the key equation is total momentum before equals to total momentum after. Now, foundation students often do one of this formula. Higher students often do it both moving and with directions. Now, using those directions, which is a higher skill. So, let me just go back to the previous one. There you go. Now, explosions and collisions, how do we spot them? Momentum conservation applies to both collisions, which objects hit each other, and explosions, one object splits into parts. Now remember, if an object explodes at rest, the piece moves off in the opposite direction, so the total momentum actually has remained the same. Now going on to the force and change in momentum, as we can see, we've got the diagram, which is force is equal to m, which is ma, which is the Newton's second law, and a is going to be the v₁u, which is acceleration. So when a force acts on a moving object or an object able to move, it causes a change in momentum. Now the rate of change in momentum depends on the shorter time and the longer time. It's all in front of us what we need to do. If you increase the collision time, the force is smaller because the same momentum change is spread out over a longer period of time. Things like airbags and crumple zones basically do the same. We need to ensure that we learn all about their rearrangements. That is the common area where students lose a lot of marks. Then we talk about some safety features. They've been explained here quite well. Crash mats, seat belts, airbags, helmets, etc. Now there are some interrelated equations which we need to rearrange. AQA, just to let you know, loves rearranging equations. So here are some common ones. What my suggestion to you is, every time you see my videos, you need to pause them, make notes, and then go forward. The key takeaway or a typical AQA momentum question: when you see a momentum problem, do this every time. Write down what's given, choose a direction as positive, calculate the momentum before and the momentum after, and use them to have to be equal to each other. Now, I hope you've understood this. I hope you know what conservation of momentum is, safety features, and what actually momentum is. I will be uploading a lot of questions on momentum as well for physics, so just please stay tuned and do not forget to subscribe, guys. Thank you ever so much for watching this video.